In this video, we will learn how to write the claim for hypothesis testing. So first off, when we're doing hypothesis testing, we will always have a null and alternative hypothesis. And these will always contain a statement about a parameter. So remember, the parameter is about the population. So that could be the mean, that could be our population standard deviation, that could also be our population proportion. So we're going to be given sample means and sample standard deviations and sample proportions, and we're going to be using them to test the claims about the population. Because remember, we're never going to be able to have the entire population, or it's going to be very rare. So we're going to be working with samples to see if we can figure out these claims about the entire population. So our first example here, we have going back to the Harris Health Systems, 87% of their employees get the flu shot every year. And we had a sample of 300 employees, and it said 249 received their flu shot in the last year. So first off, we want to know what's the claim. So they claimed that 87% of employees got their flu shot. So 87% got the flu shot. And what we want to do is we want to write this in statistical terms. So this 87% is a percentage, and usually when we see percentages, these are proportions. So we're going to say that the proportion, our population proportion, they're claiming that that equals 0.87. Now what they found in their sample, and the sample population proportion is this thing called p hat, and they found in their sample that 249 out of 300, or about 0.83% of their, so 83% of their employees got, in the sample, got a flu shot. So we want to see if this 83% is believable that the actual population percentage is 87%. So we want to see if this claim is true or not based on this sample that they provided. So to write the null and alternative, the null is always going to be, again, include our parameter. So it's going to include our p, and it's always going to have an equal sign. So the null is always going to be equal, and then it's going to equal what our claim here was, so 0.87. So this is our claim, and our alternative is going to be not equals. So the alternative can include either not equals, less than, or greater than. And the null can only have equals. So the null is always going to say, yes, it equals that percentage, or that mean, or that standard deviation. And the alternative is going to say it's different than that. So this one was different. It's going to be not equal to, and we'll see in next one's greater than and less than. So in this case, because we have a not equals to, this is a two-tailed test. And it's called two-tailed because if we look at our normal curve, we want to look for greater than or less than. And for this particular one, we want to see if we're saying the mean is actually 0.87, what is the chance that we're actually going to get that 0.83? So if the chance of getting the 0.83 is really low, we're going to say, oh, their claim is probably not true. And if the chance of getting the 0.83 is really high, then we're going to say, okay, their claim, we don't have evidence that it's not true. It could still be true, that it was actually 87%. So that's the point of doing the hypothesis testing. We're seeing if the chance of it happening is a low chance or a high chance. So we'll talk about that more in later videos. So we're going to do another example here. We have, according to the National Center of Health Statistics, the mean weight for an adult female is 164.7 pounds in the US. So we have the mean weight, 164.7. And a group promoting healthier eating habits says that they made an impact on their community by reducing the mean weight. So they said they reduced the mean weight. And they found that in their sample of 39, their weight was 161.9. So we want to know if we can actually say that the mean weight of women in this community is lower than 164.7 pounds based on their sample getting a mean of 161. So we saw that the claim was that the weight of women in this community is lower than 164.7 pounds. So mean, the population parameter for mean is mu, and we want lower. So lower is less than 164.7. So our null is always equals. So in this case, it's going to be the mean equals 164.7. And what we're testing here is if there is evidence from their sample that they have made the mean weight less than that. So what this would look like, this would be a left-tailed test. So it's called a left-tailed test because we have the left tail filled in. So we're looking for the left percentage here. So we're saying if the mean was 164.7, and we're saying that they got a value of 161.9, we want to know if this 161.9 is significantly lower enough from the 164.7 to say that they actually reduced the weight. So that's what we're looking for in these problems. We want to see if there's actual significant evidence that it was reduced in this question. So to sum things up, the null hypothesis will always have an equal sign. The alternative hypothesis could have not equal, less than, or greater than. And remember, our less than is the left-tailed test. So we're looking at this section down here. So that's left. And our greater than is the right-tailed test because we're looking at this end of the curve. So that's right. And we're looking for the next one is a two-tailed test. So that's our two-tailed test in both directions. So that is how you write the claim for hypothesis testing.